Hey, this is 8th grade lesson 8.2 over dilations, and we're going to be looking at specifically dilations in the coordinate plane. Now, I normally don't do this second, but whenever I copied off your packets, this is what came out second. So this is going to be actually the first page in the packet because I forgot to copy the first one. But this is the first page in the actual stapled packet, but this is your second lesson. Now, the goal for today is I can dilate a figure in the coordinate plane, and this is actually pretty easy. So first you need to know to dilate means to either enlarge or shrink a figure. If the scale factor is less than 1, the figure is going to shrink or get smaller. If it's greater than, should be greater than 1, not greater than 2. If it's greater than 1, it's going to enlarge or get bigger. So we look at scale factor, it's growing or shrinking, and it's growing or shrinking at the same rate, which means all sides are shrinking by the same scale factor or amount. But the angles are going to stay exactly the same. Now, to do this, what we do is you first find the coordinates of the vertices. So you look at the figure that you have and you find those coordinates. You then multiply your coordinates by whatever the scale factor is and you plot your new points. Now this is only going to work with dilations that have the origin as the center, but those are the only ones that you're going to be looking at. So this is the process that you need to use. So here we have our triangle STU, and we want to dilate by a scale factor of 1/2. So I'm going to first find my coordinates. So S is at -4, +3. T is at +6, +6, and U is at +4, -2. Now I'm going to take every single one of these numbers and I'm going to multiply it by 1/2. That's how I dilate. So -4 times 1/2 is -2. 3 times 1/2 is 1.5. So those are going to be the coordinates of S prime. 6 times 1/2, or that's the same as 6 divided by 2, is 3. So this is going to be at the coordinates 3, 3. And then 4 times 1/2 is 2. -2 times 1/2 is -1. So here are my new coordinates. And so I'm going to go through and I'm going to plot them. So -2, +1.5. Here's -2, 1.5 is about here, halfway through. 3, 3, that's really easy. 3 over 3 up. And then 2, -1, right 2, down 1. And you notice all of the points in this triangle were in different, what is the word I'm looking for? They were in different quadrants, and they're still in different quadrants. Now I'm going to draw lines to connect them. So here we go. Here are my lines. And this is the dilation of triangle STU. And you notice this line ended up exactly on the line. It actually worked out that way. It doesn't always work out that way. So this is S prime, T prime, U prime. So it's just the letters with the apostrophes. And you do need to include those. So I'll go ahead. Oh, what am I doing? I don't want to do that. Hit the wrong box. So this is S prime. Oh, I'm having a horrible time with my mouse today. S prime, T prime, and U prime. And of course it skips to the next one because this is how my mouse is working today. Here's U prime. Okay, so there is my dilation. Now we're going to look at another one, dilate by a scale factor of 2. So again, I want to find my original coordinates. So I find the coordinates for A, B, and C. A is at 2, 1. B is at 3, 2. C is at 5, 1. Now to dilate, I multiply every number by 2. So 2 times 2 is 4, 1 times 2 is 2, 3 times 2 is 6, 1 times 2 is 4, and 2 times 5 is 10, 2 times 1 is 2. So here are my new coordinates. So I graph it, here's my new figure. And here's another cool thing that you can do. Because the origin is the line, what I can do is I can draw a line from my origin to my points, and it's going to go straight through both my new point and my reflection. and I'm getting a phone call. So I'm going to stop this video before I draw my next line, and we'll go over this again tomorrow.